here's our last measurement. Now, just to let you know on your data table, you may be wondering why there's a period squared in there. So once you find the period, you square it, and then if you plot the period versus the lengths, you'll be able to find the acceleration of gravity. So what I did in the first after the first exercise, just to give you an idea of how to calculate the period theoretically and experimentally. What we're going to do actually, if you plot all the data together, and that'll iron out any of the inconsistencies, get the best straight line possible, then the slope will be proportional to g, and you can actually calculate the slope from g. So let me just take this last measurement, and I will tell you how to find that from the slope. Ready? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 8.74 seconds. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see it's getting really fast now, 8.62. Again, this is at 0.200 meters, 0.200 meters. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8.69 seconds, 8.69. So 8.79 seconds, 8.62 seconds, and 8.69 seconds. Okay, so about what I said before, remember we used this, the t equals 2 pi L over G, 2 pi times the square root of L over G. Let's rewrite that down here. T equals 2 pi times the square root of L over G. Now, we want to take advantage of the fact that we did this for many different lengths, 3 trials each. That'll iron out some of the errors I have. Like if I only did it for one length, what if I had, misjudged the length slightly or something like that? So what we want to do, to get rid of the square root sign, if we want to plot things, we want to plot the t versus L. First we square the t, so we get 4 pi squared, and the square root sign goes away, then we have L over G. So I'm going to rewrite that. T squared is equal to 4 pi squared over G times L. So that is an equation of a line with 0 intercept. The slope is 4 pi squared over G. So remember the equation of a line, y equals mx plus b. So in this case, y is t squared, so that means you put t squared on the y-axis, the vertical axis. L will go on the x-axis, okay? The slope will be equal to 4 pi squared over g. Don't worry, you're going to probably get some sort of y-intercept. So what does that mean? So let's write the slope. So what you're going to do is plot t squared versus L. You're going to find the slope. That's going to be equal to 4 pi squared over g. So how are you going to find your value of g from that? Well, you just invert the equation, solve for g. Just flip these two around. So g would be equal to 4 pi squared over the slope. So again, for exercise number 1, once you get your line, plot the line, t squared on the y versus L on the x, corresponding L's. Find the slope of the line, and you can find the gravitational acceleration from it. And in this case, you can find the percent error because we know it's very, very close to 9.80 meters per second squared at sea level. And we're close to sea level where I'm at. I mean, I'm not exactly at sea level, but I'm not going to do that correction. So percent error between the experimental G and the 9.8 meters per second squared.